This is a circle theorems question, and there's going to be two circle theorems that we need to use. The first one, I'm just going to draw a little sketch. If you have a triangle like so and you have a tangent, then this angle here is the same as this angle here. It's called the alternate segment theorem. And therefore, in our case, if this is 70, then this is 70. Now it says show your working, so I'm going to write down the angle BAD equals 70 degrees, and I'm going to quote the alternate segment theorem. I'm not going to prove it here, or maybe I will at the end if I fancy it. Okay. Right, what next? Well, there's something else going on. We actually have a cyclic quadrilateral here. And that means I can work out this angle here. It's going to be 110 because the two must add up to 180. So angle BCD is 180 minus 70, which is 110 degrees, cyclic quadrilateral. Is that enough? Maybe I should write a little bit more. Opposite angles in a cyclic quadrilateral add up to 180. Okay, so we've already used two circle theorems. We're not done yet. Now we've got the ratio part. The ratio of angle BCD to angle BCD, that's the one I just found, to CBD is 5 to 2, and they want me to find CBD. So I'm going to draw a little bar model here. I've got 5 parts, and I want to work out what 2 parts is. And I've got that this amount is 110. So if I want to work out what 1 part is, I can do 110 divided by 5. To do that quickly, you can actually divide through by 10 and then times through by 2. It's going to give me 22. You can do a short division if you prefer. So then that's 1 part. And so I'm basically done, because 2 parts is going to become 22 times 2, which is 44. Quite a lot going on there. Now I did say I might have proven this circle theorem, and I think I'm going to have a go at it. I'm going to use another circle theorem to do it, so I'm sort of going to do it the quick way, but that's absolutely fine. I've got a circle, I've got a tangent, and I've got a triangle. Now let's say that this here is x. I'm going to prove it generally. Well, what I can do is I can put the center of the circle in and draw little dotted lines to show the radius. Now I'm going to use other circle theorems. So this angle here is actually going to be 90 minus x, because a tangent meets the radius at 90 degrees. Because this is an isosceles triangle, this will also be 90 minus x. And therefore this angle here, when I add these two together, I'm going to get 180 minus 2x. For the triangle angles to add up to 180, which they must do, then this must be 2x as well. And it follows from the angle at the center being twice the one at the circumference that this must also be x. So pretty neat. It doesn't seem at all obvious when you first look at that to say that they'd be the same, but we've proven it using 2 other circle theorems. Of course, I've not proven those 2 circle theorems, but those might have been ones you've seen before, or at least you're happy to accept.